You just said it. Somebody said it. Thank you. It's the x values that work for a function, right? Yes?
Yeah.
Okay, the range is the set of y values that work for a function. I'm going to ask you again, what did you just tell me we do to find an inverse function? Switch x and y. So when I find the inverse function, what do you think is going to happen to the domain and range? Ding, 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 ding. Winner, winner, chicken dinner. Extra credit, Chris. Hey, the domain and range will just be flipped. So the range of my original function is going to be the domain of my inverse. The domain of my original is going to be the range of my inverse. Does that make sense? Are we sure? Okay, I want you to write that over here, and then we're going to do an example. Will be the range of the inverse and vice versa. Are y'all fine if I just say it one way? Can I put vice versa at the end? Okay. Is that better, Chris? I'm read it to you. The domain of the original function will be the range of the inverse function, and vice versa. You've got the worst seat because you are farthest away from my thing. If you ever want to move over here, you definitely can. Are we okay with that? Do we understand why that works? Okay, we do understand why it works. Tell me, why does it work? Good, KJ, extra credit. Because the x and y values, we're switching them. So all the y's that were in the range are now going to be the x's in the domain. We're just switching them. Y'all can't tell me you get something and then not be able to explain it to me. Okay, I'm going to quiz you. Huh? You don't want to talk? What if I didn't want to talk one day? What if I was just like, y'all are just going to watch a video today and learn it on your own because I don't want to talk? I don't know, Chris. All right. F of x equals, I will never, even live, was it last, it was 2 years ago, my grandpa died and I found out at school and I cried and I got over it in 10 minutes and I still taught my class. I won't make y'all watch a video. Oh my God, I was crying in front of my kids and they didn't know what to do. Yeah, they were like shocked. I was like, I'm really sorry. I just found out my papa died. And they were like, oh my God. And I was like, it's okay. Just give me like 10 minutes. All right. They gave us this function and they ask you, let's do A, they want the domain of f of x. And then part B, they want us to find the inverse and its domain and range. I had teachers in high school who would make us watch videos and figure it out on our own. I hated it. Huh? D and R, domain and range. Sorry. I tried to squeeze it. I'm trying not to waste another piece of paper. All right. I really hope everyone is okay with A. You have 2 of these on your quiz tomorrow. Please don't miss this. How do we find the domain of this function? Huh? Okay, by looking at the x's, what kind of function is this? Somebody said it. Rational, because it's a ratio. What do we know about fractions? What can the denominator not be? There.
0.
Oh my God. Good. Sorry, Grace, you scared me. So the denominator cannot be 0. Somebody came on and said 0, but it was like really loud. I was like, oh gosh. So what would the domain be? That means x cannot be what? Good. Thank you, Pradnia. X cannot be 5. You okay? Oh my God. Thank you. X cannot be -5. Thank you. Thank you. Thank you. The ADHD is real. I told y'all you got to correct me. Thank you, Mary. Well, I realized because she was looking at it like I wrote something absolutely ridiculous. X cannot equal -5. So how would we write the domain? Come on, Ross, speak up. Negative infinity to -5, and it can't be -5, so I'm going to use parentheses, right? What comes next? Good. Pick it back up at the whole, -5 to, there we go.
I don't get like the brackets and parentheses.
Brackets you use if it can equal that number. Okay, if it can equal that number, you would use a bracket. Now, Pradnia is like, when would it ever equal? It won't if you're doing domain. Got me? Never, because do we know? Do we know what number infinity is? No, we just know it's infinity, right? But you cannot see infinity, so you can't use a bracket. Now, I just said never, and nobody corrected me. For this one, a square root function, you don't have to write this, just look at it. What do we know about the inside of a square root? It can't be negative, which means it has to be greater than or equal to, there we go. So x minus 3 would have to be bigger than or equal to 0. So if you add 3 over for this one, do y'all see how it has the equal bar right there? So when you write this one, it can equal 3. That's when you would use a bracket, and then it would go all the way to infinity. Okay? All right. So this is my domain of f of x, right? Yes, thank you. So that means this is going to be the what of the inverse? Good. So guys, you already know the range. It doesn't take any work. Negative infinity, -5, union, -5 to infinity. That's the range. I'm so sad because I'm going to run out of room. Maybe. I'm still going to try to make it work. All right. Are y'all okay with that? Please ask me a question if you are not. So because it can't equal -5, if I were to graph this, are you okay if I speed graph? Okay. So this is a rational function. You'll learn today rational functions look very interesting, but basically at -5, there is an asymptote. Do you guys remember learning about that? 5. There's like a barrier at -5 because that's what would make it undefined. So this graph is going to approach -5 and it'll look like this. Do you remember seeing graphs like that in Math 3? Okay. So where it's undefined, there's an asymptote. We're actually going to talk about that next unit in more detail. Good question, KJ. That wasn't a dumb question. There are no dumb questions unless it's something I literally just said. Like if I tell you the homework is 1 through 7 and then you ask me what's the homework, I'm going to just stare at you. Okay? All right. What did they want us to do for B? Find, no. What do they want you to do first? Reading is hard. Find the inverse, f inverse of x, right? So how do I find the inverse of this function? Switch x and y. So this is going to be x equals y minus 3 over y plus 5. A lot of us needed help with this one on the homework. Right? No shame in that. That's okay. It's a little weird. A couple of you did hop on office hours. Can you tell me my first step? Even if you didn't. What do you think we need to move first? Okay, but what's with the 5? Good. You always have to get rid of the denominator first. We cannot solve anything with junk in the trunk. If you had me for math 2, that's what I called it. Okay? So I'm going to multiply both sides by that denominator to get rid of it. Okay? And they'll cancel over here, right? So now somebody talk to me. Am I going too fast or are y'all okay? We're okay? Okay. Talk to me. What do I have on the left side now? Simplified. What would that be? Oh, good. Yes, children. All right, let me take you back to math 1. If we had an equation like this in math 1, what would we do next? Get the x's on the same side. Aren't we trying to solve this for y? You can't do that until you get the y's on the same side. So I need to move this y over here, correct? Anything that doesn't have a y, I need to move to the other side. Are y'all with me and Mary? Okay, just watch. I need to get my y's together so I can solve for y, right? And those will cancel. And then this 5x does not have a y in it, so I'm going to move it to the other side. If it confuses you doing it in the same step like this, don't do it in the same step. I'm going to do this so y'all can see better. So what do I have on the left now? Good. What do I have on the right? And I'm going to put the 5x first, if that's okay, because I'm going to put it in standard form. Is that okay with everybody? Okay. All right, we're going back to math 1 and math 2. You ready? Taking another field trip. So don't look at that one anymore. Look at this one. In math 1 and math 2, if I asked you to solve this equation for x, to find x, what would we do? Will it help if I set it equal to 0? How do you get 1x? How do you find x? It's in 2 different places. So that's what makes it tricky.
Factor?
Oh, yes, Grace. Extra credit, girly. Factor. You would take the x out of both of them, right? Don't they both have x in common? So in math 2, you would do this. You'd take it out, and then you would just be left with x minus 4, right? Yes, and then you would set them both equal to 0. Oh, okay. Let's look at this. What do they both have? A y. So what can we take out? A y. What are we left with? An x minus what? Thank God. I was praying you would not say 0. That is not 0. That's an understood 1y, correct? Okay. Equals negative 5x minus 3. Excellent job, Grace. And then how do you get y by itself? What's the x minus 1 doing to the y? The parentheses be multiplied, so the opposite of multiply is 2. Good job. Those cancel. So guys, this is your inverse right here. That was a lot of work, right?
Yeah.
I would really make sure I know how to do this one Why am I saying that? Yeah, both. This is a pre-cal question. Okay? That is our inverse. Now, make sure everybody's done writing. Natalie, you okay? Okay, you're just so quiet today. I'm not used to that. That's my inverse. How do I find the domain? Yes, Drake. What about the denominator? Drake is on it. Oh, he went ahead and solved it and everything. So the denominator can't be 0. So for the domain, he's saying x minus 1 cannot be 0, and he went ahead and solved it. So x cannot be 1. Do y'all agree with Drake? All right, so how do I write that? Not everyone at once. That was sarcasm. How do you write the domain? There we go, negative infinity to 1, u. There we go. Here's your domain. I'm about to take it a step farther. It's okay, just look at it. If this is the domain of the inverse, that means it's the what of the original? Very good. Are we okay with domain and range? Are we sure? Beautimous. All right. Can I close this for now? Let's look at your homework. I'm looking at it quickly. So I don't feel like I need to do number 3 now. Do you guys want me to do number 3? Or can you just check mine? It's up to you. If you need to see it one more time, I can do it. Just talk to me. Which ones do we need to see? We're not going to worry about 12. We'll do that as a warm-up tomorrow, okay? 7, 10. Those are good ones. Any other ones besides 7 and 10, people at home?
Thirteen.
13B, absolutely. 7, 10, 13B, is that it? Yes? And then I'll let you check my answers. Okay, so for 7, make sure people at home can see. I'm gonna keep quizzing y'all. How do I find the inverse? Yes. Y'all make sure you're ready to answer. So people who are really good at math, it's not because they do really good computations, it's because they understand it and can explain it and use words for it, okay? Switch X and Y. What am I solving for? There we go. And also sound confident when you're answering. You guys are all smart, okay? Solve for Y. Use the cover method. It's easiest. Cover everything that the Y is attached to right now. What do I move first? Minus the 7 over here, right? So x minus 7 equals the cubed root of 2y minus 5. Now, I'm going to go ahead and tell you this for your quiz. Unless it says put it in standard form, you don't have to put it in standard form, okay? So what's the opposite of taking the cubed root? Cubing it, right? Cube this side. What you do to one side, you got to do to the, and then the cube and the cube root just cancel out, right? So we're left with x minus 7 cubed equals 2y minus 5. Good. So what do you do next? Add the 5 over. So x minus 7 cubed plus 5 equals 2y. And then divide by. Very good, y'all. Good. This is a really good one to know how to do as well. Yes. on, like for this, I need to see at least a couple steps. So this one where you've switched X and Y, I need to see. And then I should really see this one as well. Okay? Just for quiz and test purposes. People at home, are we okay with 7? People in class, y'all are good?
Yes, I'm fine.
Thank you. All right. Number 10. Rocking and rolling. Number 10. This one is tricky. These are the ones we're going to learn about today. Do you guys know what kind of function this is? It's a special kind of rational function because, yes, it is a ratio. When X is in the denominator and only the denominator. That's okay. We'll talk about it today. It's called a reciprocal function because it's flipped. X isn't in the top, it's in the bottom. So it's the reciprocal. So a reciprocal function is really cool because it automatically reflects over the line y equals x. You will learn that today when we do our parent graphs, okay? So this graph automatically looks like this. It'll either look like that if it's positive, or it'll look like this if it's negative. But either way, it's reflected, right? So this should automatically be inverses of each other. But we are going to check. How do I check to see if they're inverses? Composition. This is the other part of your quiz, composition. So I'm going to take 7 over x and input it right here, right? Okay, so that's going to give me 7 over x. Now, no one freak out. We did this the very first day, right? The first day we did math. Can we divide by a fraction? So what do? Multiply by the, there we go. So keep this 7 on top, times instead of dividing. And then what's the reciprocal of this? X over 7. What happens with the 7s? So you're just left with. Now this is the only function I would be okay with you not plugging it in twice. Can somebody tell me why? They're the exact same thing. You're going to get the exact same thing. So when they are the exact same like this, you don't have to do f of g and g of f because it'll be the same. But when they're different, I should see it both ways. We okay with 10? Okay. Can I erase? And then 13b. I'm just going to go ahead and do all of 13 because I'll need to see the inverse to be able to do b. All right, so this is talking about converting Fahrenheit to Celsius. So the first thing you had to do is find the inverse, right? Okay, can I do it quickly but talk through it since y'all said you were okay with it? So switch X and Y. And I'm going to use a C instead of a Y because that's what they used over here, okay? Just so y'all can see it. All right, so do you guys see how the C is on the inside? That means the first thing we would have to move is the 5/9, but you can't divide by a fraction, so what would we do? There we go, multiply by the reciprocal on both sides. Okay, the 9s cancel, the 5s cancel, that's why that works. So we have 9/5 x equals Celsius inverse minus 32. You okay there? Okay, then you would just add 32, right? 9
Yes.
x plus 32 equals Celsius inverse.
Doing things the wrong way and getting this right answer.
I'll come look at it. It may not be the wrong way. I'll come look at it. Okay? All right, so that's my inverse. Now I want you to interpret the meaning. Let's talk about what they told us in the problem. The problem said it's converting what to what?
Fahrenheit to Celsius.
Read the problem. Good. Fahrenheit to Celsius. I just took the inverse, which means I took the input and the output and I switched them. So what is the inverse function finding?
Celsius to Fahrenheit.
Celsius to Fahrenheit, not Fahrenheit to Celsius, Celsius to Fahrenheit. That's it. That's all you had to tell me. Does that make sense? Okay. All right. You guys talk to me. Let me know how you're feeling. I'm going to give you two options, but I am going to tell you which one I, as the teacher, think is probably better, but I will let you pick. Got it? Okay. You have a quiz tomorrow. So I was hoping to get through the majority of the stuff today so that you don't have a lot of homework so you can study for your quiz. So in order to do that, I don't really have time to show you all the right answers. Option one, you guys can be like, no, I want to see all the right answers now. I'll have more homework. Option two, I'll post my answer key on Canvas. You can check it later on your own time, and we'll have less homework so you can study more for your quiz. Which one? One or two?
Two.
Are we okay with that, people at home?
Yes, ma'am.
Okay, I will post my answer
Yes.
later. So for you guys, go ahead and get out your notebooks. And where is mine? It's up here. Topic 4 is the library of functions. And we only have 2 more topics, and then you are done for this unit. I did print your notes. You are welcome. It should be pretty easy. I am going to use a PowerPoint. I despise PowerPoints, but me and Miss Kane made a pretty good one for this a couple years ago, so I am going to use it. Do y'all need like a 30-second break to check your phone? And yeah, I feel like I've lost some of you, so take a break for a second. While they're taking a break, online people, how y'all doing?
Good.
Good?
Doing all right.
Oh no, who said all right?
Me.
I don't know. I have you like turned off on the side. Who's me?
Chloe.
Okay. Are you okay?
Yeah, I'm just tired and my dog wants attention.
Oh, I wish I was at home with my dog. My dog's at daycare. Y'all are like, your dog goes to get daycare? She does. She goes, runs around all day. Yeah, the life of a dog, man. And then she comes home and I feed her and she gets rubs, like the best life. No work, no responsibilities. She did get a spanking this morning though, because she chased the neighbor's cat and literally scared the SHIT out of the cat and then ate the SHIT. So that was fun.
Oh.
Gross. My dog is gross.
What type of dog is it?
He's a hound dog. Oh, I can show y'all a picture later. But she's like, she comes up to about my hips. She's very tall, but she's very skinny. She's got long legs. And
My dog also has very long legs. We call her a deer.
yeah, mine looks like a deer too. I'll have to show you a picture. All right, little phone children, have we had a break? Yeah, we're okay? Okay. I'm going to do my best. I have to flip back and forth between a PowerPoint, people at home, and back and forth between this table. If you are at home, I posted this for y'all, but you do not have to print it. You can copy it into your notebook, okay? So my suggestion, if I'm going too fast for you while you're at home because I'm flipping back and forth, just like pay attention now and you can fill in the table later, okay? And I may not even use the PowerPoint. Are y'all fine if we just fill in the table together? Okay, let's try it that way. If I need the PowerPoint, I shouldn't, but if I do, we'll flip to it. All right, so when I say library, what do y'all think of? A library. Lots of books, right? Books on what? Anything, right? Kids books, science books, math books, fiction, Harry Potter, Twilight, whatever kind of weird stuff you're into, right? I can say it's weird because I like it. Okay, so library of functions means all the different types of functions, any kind of function. Now, how many are on this sheet of paper? 5. These are the 5 most important ones for this class. Capiche? Now, another really important one is a linear function. I'm really hoping that I do not have to tell you how to graph a line. I will be very depressed. What's the equation of a line look like? Yeah, you were about y equals what? Yes, Oswald, extra credit. Y equals mx plus b? What is the b? The y-intercept, that's the base of your graph. That's where you start, right? Okay, great. And then what's the m? Oswald, you are on it, man. So just to review, because you guys are staring at me and it kind of scares me. I don't know if you're staring at me because I look cute today or what. My freshmen always be like, Miss Poole, you always look cute. I'm like, oh, thank you. I did win best dress last year. I got to defend my title. All right, if we are graphing y equals 2x minus 1, where does my graph start? Where's the base? -1, and we just said it's a y-intercept, right? So you go to the y-axis down to -1, put a point. What's my slope? 2, so I go, okay, great. We don't need to review this, do we? This is how you would graph a line? Okay, great. People at home, we're okay?
Yes.
Okay, good. Y'all pray for me because next week I have to teach that to my freshmen and my ones this year seem a little wild. So it should be real interesting. All right. You should know how to graph a line. You don't need to know a parent table for that because you guys know how to graph it very quickly. A quadratic. This is the first very important one. Parent function. What does the equation of a quadratic look like? Good, just x squared. The parent function. Now, when I say parent function, what does that mean? Just the very original one, just the basic quadratic. Parent function also means that all of these should be starting at the origin, 0, 0. Did y'all learn that in Math 2 and Math 3? Okay, good. So this is my parent function. What else does this column say? And table. You need to know this table for a quadratic. -1, 0, 1. Those are my x's. What happens when I square each of those x's? What do I get? Let me help. Thank you. I was about to say, Lord, I got to help y'all out this morning on this Monday. What's -1 squared? Okay, great. What's 0 squared?
0,
Thank you. What is 1 squared?
1.
There we go. Y'all see what I did? This is your parent table for a quadratic. You need to know this for tomorrow, not for your quiz. None of this is on the quiz. I will not give you a quiz on something I taught the day before. Your quiz is only compositions and inverses. Got it? Okay. You need to know this for the lesson tomorrow. Sound good? Okay, so if you graph these 3 ordered pairs, -1, 1, 0, 0, and 1, 1, This is what your graph of a quadratic looks like as the parent function, right? Thanks, Chris. What is it called if we move that graph around? Okay, it can be reflected.
Transformation.
Who said that?
Kindle.
Thank you, Kendall. Extra credit. Transformations. We can shift it up and down, left and right. We can reflect it. We can stretch it or compress it. Good. Do you guys remember learning that in math too, I believe? Great. That is what we're doing tomorrow and Wednesday. Except Wednesday, it does get harder. It's okay. You should be good tomorrow. Parent function. What's the domain of this graph? Good, guys. Domain means x's, right? And these arrows go all the way to the left and all the way to the right because they keep going, right? So the domain, I agree, is negative infinity to positive infinity. What is the range? Good. It starts at the origin, right? Range is the y's. So find the bottom y, the lowest y is 0, and then it goes up forever. So it does go from 0 to infinity. And there is a point sitting on 0, so you do need a bracket. Does that help? Okay. All right, look at all these lovely things to the right. They should, oh, I love them. These are so easy. It's like, girl, I got you. I got you. No, it's way easier than they probably made you think it is. I got you, okay? For the first 2, I am gonna review this stuff, but then your homework tonight for the last 3 is to fill those in on your own, okay? And I shouldn't say on your own, the PowerPoint is posted, so you may be able to find some of them in there, okay? And you can use Google. If you can't find it, Google will let you know. Everybody's good. Intervals of increase and decrease. Which side of my parabola is going up? No. Good. Think about a roller coaster. If you start here, this side is going, and then this side goes back up, right? So it is increasing on the right. Can you guys tell me when? I'm saying when for a reason. Let's see if you can pick up on it. When does this graph increase? Good, Drake. I'm hoping he said 0 because the x value is at 0, not the y. Can I use a real world example? Okay, my track runners or even soccer, whoever, everybody knows how to run. We're born knowing how to run, okay? So if you go out to the track and I tell you to run a lap, is everybody with me? When you get done, no one's gonna ask you how far you just ran. They already saw it, didn't they? They're gonna ask you what? How fast? What was your time? Okay? When we talk about something increasing or decreasing in life, we are almost always talking about the time. So when you see increase or decrease, I'm talking about the x values. Don't give me the y's. I want the x's. When is it increasing? When is it decreasing? Does that make sense? Okay. So look at the left side of your parabola. We just said this side was going down, right? This pen sucks. Sorry, y'all. I meant to throw that one out the other day. The left side is going down. So when does this graph decrease? There we go. Oh, and no one corrected me up here. I'm so sad at myself. Should I be using a bracket? I don't know, maybe. No. Look at 0. When we are at 0, are we increasing or decreasing? No, what are we doing? Just chilling. So we're not doing either at 0, so there should not be a bracket. Good. All right. Is that ringing a bell? Okay, I hope so. All right, this one's easy. What are our intercepts? What's the x-intercept? 0, 0, great. What's the y-intercept? Fabulous. You should be able to look at a graph and know the x and y-intercepts. Don't really feel like that's anything I need to teach you. If you ever have a question though, holler at me. We okay with that one? All right, let's keep rocking and rolling. End behavior. I feel like the notation probably confused you in Math 3 because it was probably written on the board and you were like, what the heck does this mean? Okay, great. Let me talk to you about end behavior. Very easy. As x approaches negative infinity, what does that mean? Which way is negative infinity? Point for me. So as x is going to the left, all you're doing is telling me what the graph is doing. So as x approaches negative infinity, as x goes to the left, what's the graph doing? Going up or down? Okay, look at the arrows now. We're done with the, so what's it doing? What are the arrows pointing? Up. So as x approaches negative infinity, y approaches positive infinity. We're talking about the y. The y is going up. We're not just reading the graph from left to right now. We're looking at the y values, okay? What happens as x approaches positive infinity? Okay, look at your graph. Look at the right side because x approaching positive infinity is the right, right? Okay, it's also still going up. So it's still y approaches infinity. Why? Not like y, the letter like W-H-Y, question mark. Why? Why do they both go to positive infinity? Because the graph is opening up. It's just like in Math 2 where we asked you which way does the graph open. If you had me, it always said opens question mark. It's opening up. So the end behavior should be infinity for both ends. Is that better, Mary? Okay, good. It's not hard. Depends on the graph. Now let me ask you a question. If we take our quadratic and we reflect it, what's the end behavior going to be for both of them? Good, negative infinity. So it just depends on the graph, Ross, okay? Very good question. All right, concavity is just a funky math name asking you how it opens. Okay, so it's up. So you would call this concave up. You need to know that word concave for if you go on to pre-cal. And I'm not trying to be petty when I say this, but if you're not, or not pre-cal, calculus, if you're really not planning on taking calculus, I'm not sure why you took this class. Not trying to be petty at all. I'm being dead honest. So concave, you need to know for calculus. Cool? If you're like, I don't want to take calculus, but you want to be an engineer, statistician, business stats person, math teacher, anything medical, you will have to take calculus. It's not that bad. Pre-cal's harder. Don't ask me why. I don't know. It just is. It just is. I've been through them all, I promise. It just is. Pre-cal was harder than any of the calcs I took. I think there's more content. Are we okay with a parabola? Okay, let's go down. A cubic function, what is the parent function or the parent equation? Good, y equals x cubed. So our table that we need to know for tomorrow, we're going to use -1, 0, and 1 again. Anytime we can use -1, 0, 1, we are going to use them because they are the smallest numbers to plug into an equation, okay? What happens when I substitute each of these in for x cubed? What do we get? Good, -1 cubed is -1. 0 and good. So when I go graph these, -1, -1, it looks like they make a line, correct? Do not correct them as a straight line. It's obviously not a straight line because it says cubed, right? Do you guys remember from Math 3 what kind of shape these graphs have? Kind of like a S, kind of like a flattened S. So you guys are saying like this. I told you I'm not a good artist. That was actually pretty good for me. You need to know this table again for the lesson tomorrow. All right. I am going to do the domain, range, increase, decrease, intercepts, and behavior of this one. Then for the other ones, I'm just setting y'all up with the tables and graphs, or really probably just the tables, and you'll finish for our homework. Sound good? That should not take you long at all, though. So, domain of this graph. Talk to me. What's the domain? What are the X's? So this bottom arrow goes to the left forever. The top one goes to the right. So that means it includes all numbers. So I agree, negative infinity, infinity. What about the range? Huh? It would. Why? It goes down forever and it goes up forever. So the range is also negative infinity to infinity for the y's. It's not like this one up here where it started at 0, because this one, when we square something, we don't get negative numbers, do we? No. But when you cube something, you can get negatives or positives. Depends on the input, right? Yes, no. Okay. Increase, decrease. What is this graph doing? Are you sure? When you start, okay, so let's do this one more time. I'm going to zoom in really, really far. When you start on the left of this graph, it is like a roller coaster. You go down and then you come back up, right? Always start on the left. When you read a book, you start on the left. When you read a graph, start on the left, okay? So when I go to this graph and I start on the left, what do you do? No. If you were like climbing it, you go up the entire time, right? So this graph only increases, and that increases from negative infinity to infinity, because that is all it does. Does that make sense? Are y'all sure? Okay. All right, what are my intercepts? I was about to say, don't wait for me. Look at your graph. X-intercept is 0, 0. Y-intercept is also pretty easy. Let's talk about our end behavior. Am I going too fast or y'all are okay? Okay, let me know if it's too fast. I do not mind slowing down. As x approaches negative infinity, so let's talk about it again. Which way is negative infinity? The left. So we are looking at the left side. Where's the arrow pointing? Down. So that means y is approaching. There we go. Because it's pointing down, right? You just told me that. We're looking at the left because it says x negative infinity. And the y is going down. That's it. That's all end behavior means. I'm so sad that they didn't make it easier for you. As x approaches positive infinity, that means we're looking at the right. Where's the arrow pointing? Which means y approaches. It also approaches positive infinity. Good. All right, this question's tricky. When we talk about the opening of this graph, is it opening up or down? I'm not trying to trick you. Yeah, it does look like both, doesn't it, Chris?
Yeah.
Let me grab me a different color. Let's use this color. So from 0 to the left, it is opening down. Good. So it's concave down from negative infinity to 0, right? Let me know if you're not okay with that. And then at 0, it also turns around, and now it is opening up. So it is concave up from 0 to infinity. Do not get that confused with increase, decrease. When you read that graph from left to right, you start on the left, you are going up the entire time. That is increasing. But when we talk about the opening, the left-hand side is pointing down, and the right-hand side is pointing up. Are y'all okay with that?
Yeah.
All right, I'm gonna keep trucking because I want to have 5 minutes at the end. I told Ross I'd give y'all 5 minutes at the end for me to talk about the quiz. Square root function should look like the square root of x.
Yeah.
What numbers can we use in our table? Don't you dare tell me -1, or I'm gonna throw something at you.
1.
Okay, I can use 1. I can also still use 0. Who said what? Good. So we can't use -1 because we can't take the square root of a, but we can use the 0. We can use the 1. What's the next whole number that's a perfect square? No. Yes. Good. This is your table for a square root function. This is the one that's different that you guys will act real blonde about. I can say that because I'm blonde. No offense, Drake or Cody. Y'all be like, and you'll forget the table. And I'm like, perfect squares, 0, 1, and 4, right? What's the square root of 0? What's the square root of 1? What's the square root of 4? There's your 2. And you guys should be able to graph those. Can I keep going? We will go over this tomorrow because the notes tomorrow do not take long at all, okay? I just want to make sure I have time to talk about y'all's quiz. Absolute value, what should that look like?
Wow.
Oswald said, it should be the bars.
X. Yeah.
Yeah, that thing.
Yeah, I know that.
Good. Okay. Absolute value will always end up being good. Ross said positive. Now, can we put negative numbers into it? Yeah. So we can use -1, 0, 1 again. And then what happens with my outputs? What's the absolute value of -1? Good. Absolute value of 0. Absolute value of 1. And I think I have the time real fast, so I do want to graph these two for you guys. You're welcome. Square root function 0, 0, 1, 1, 4, 2. You guys see what I'm talking about now? It's like that one side of the parabola. There we go. It's a sideways parabola, but it's only the top part because we can't have negative square roots, okay? And then the absolute value, -1, 1, 0, 0, 1, 1. Now, it is not curved. Do you see how it's a plane X? That means it is a straight line. It just goes in both directions. Y'all remember seeing the V's? It's a V. It's a line in both directions because it says y equals x. It's just in bars. Are y'all okay with that? Are we sure? Okay. Reciprocal function. We just looked at one like this. It looks like that, 1 over x. All right. Your table for this one's a little tricky, and we do not use this one with transformations, thank the dear Lord, because they get real messy, okay? So you don't necessarily need to know the table now. You will need it for unit 3, I believe, if I'm remembering correctly. But your table for this one's a little different, okay? So we're going to use 1/2, 1, and 2. Somebody tell me why I didn't use 0. Good. You can't have, somebody said it can't be the denominator as the fraction. Ross was saying the same thing. X can't be 0. There's an asymptote there. It cannot be 0. That barrier's there, okay? What happens if I put 1/2 in the bottom? What am I gonna end up getting? 2. 1 over 1/2 would be 1 times 2, which is 2. That's okay. If I put 1 in the bottom, 1 divided by 1 is 1. And then if I put 2 in the bottom, 1 over 2 is 0.5, right? Or 1/2. So I am going to show you real fast how we graph this. 1/2, 2, 1, 1, 2/2. I told you it couldn't be 0, right? It gets really close to 0 in both directions, but it never touches them. That's called an asymptote. Do we remember that word? Okay, I teach my freshmen, you are not supposed to touch somebody's ass at school. Got it?
Yeah.
Don't touch the asymptote. It's like in Finding Nemo when they say he touched the butt. Don't touch the asymptote. And then they all giggle because I said ass in school. All right? Freeze, because some of you are moving. A reciprocal function, what did I tell you it always does earlier? Yes, it always reflects over the diagonal. Oswald, extra credit. So you guys should also reflect this over here. You don't have to do the points if you don't want, but it should always look like that. Now, stay with me. I have 2.5 minutes. I'm going to talk fast. Can I pull this down so I'm not muffled? Okay, listen to me very carefully. Your homework is to finish this. It should literally take you 5 to 10 minutes because you can use the PowerPoint. What's your main homework? Study for your quiz. Look at me. This is not Math 2 and Math 3. You ain't doing no memorization where you just read over your notes. That is the worst way to study for math. Okay? What's a good way to study for math? If you had me, you better speak up. Say it again, Ross. Do some problems. The ones we went over today, I was like, that would be a really good one to know how to do. Work it out tonight, okay? Some of your composition ones that we've done before, work some of those out. Do we understand?
Yeah.
Now freeze, hang on. That's not your only thing. You got these, and then yes, you need to study. I'm gonna post a video on how to create your student Delta Math account. You need to make sure that's done, and I do need you to bring a computer or tablet tomorrow so you can take your quiz, okay?